This video is going to walk you through how to find the multiplier and the initial value for this little table with a system of equations. But again, I want to caution you that you don't have to do the problem this way. This is an option for those people who don't want to try the guess and check method. But even if you thought you're not a good guesser and you don't want to try it, you may want to consider watching the video for the guessing strategy too, if you haven't already, just to give yourself an equal opportunity look at both methods. The system of equations method is definitely more complicated, and it definitely takes more time than guessing in some cases. So that's why I don't want to necessarily make it sound like the method I'm going to show here is the way you should be doing the problems. It's an option, just like guess and check is an option. So when you're doing these, if you get totally overwhelmed, or if the algebra here seems a little bit too much, just abandon this strategy and switch to guess and check. Because that is the one nice thing about the guess and check method, is that there's no real prerequisite knowledge needed. Prerequisite means you have to know something going in. Well, to be able to do this with algebra, you have to know and be pretty good at systems of equations going in, and that may not necessarily be your strong suit. And that's okay. There's certainly nothing to say you have to do the problems with algebra. So you decide, but if at some point during this video you get a little overwhelmed by the process, just stop and focus on guess and check instead. Ignore this system of equations thing and don't worry about it at all. If you want to find the multiplier by using a system of equations, we first need to think about what an equation for this problem would have to look like. An equation for this problem needs to be geometric. And the thing I know about a geometric sequence is that it has a general structure that always looks the same. It has an initial value, which I'll call I, times a multiplier, which I'll call m, to the power of n. That's always what this system of this equation needs to look like. I stands for the initial value, and m stands for the multiplier of the problem. Now the downside right now is that we don't know either of those letters, I or M. All we can do is plug in some stuff and work around the parts that we don't know. So this might remind you of how we do other problems, like for example, the whole plugging in and solving for an A value thing that we used to do when we did graphs. It's kind of the same logic. We're going to say, well, we don't know the initial value. The initial value comes from a part of the table we didn't know. And we don't know the multiplier either. They didn't tell us that info. All we know, and I'll just remind us of this in case we forgot so that we don't have to keep skipping back and forth between the parts of the screen. All they gave us was that the first term is 12 and that the fourth term was 96. This is all we know. That was it. They didn't tell us any other information. They didn't tell us the zero term. That would have been the initial. That would have been nice. They didn't tell us the second or the third terms. They just told us these. But they did tell us something kind of helpful. When I'm talking about the first term, that's n is 1. And the first term itself, 12, that's t of n. So at n1, t of n 12, it's almost kind of like we have coordinates to plug in. The 1 and the 12 can get plugged in to the equation that I wrote on my paper. I can plug 1 in for the letter n, and I can plug 12 in for the t of n. So a substitution, if you will. And if I rewrite this exact equation, just with the 1 and the 12 plugged in, I'd have, instead of t of n equals 12 equals, I still don't know what the initial value is, so I'll leave that as an I. I still don't know what the multiplier is, so I'll leave that as an m. But to the power of n, which is 1. So I plugged in the information that they gave me. Now right now, that's not actually a very helpful equation for me. I mean, m to the power of 1 is just m, That's cool, but that doesn't even tell me anything. I can get rid of the power of 1. It doesn't need to be there, but that still doesn't tell me any helpful info. So that's why I'm going to have to use the other point as a second substitution. This is why we call it a system, because you're going to end up needing to make a second equation with the second point that they gave us. We're going to plug in n as 4 and t of n as 96 and create a whole separate equation. So again, I'll use this structure. T of n is 96 equals, I don't know I, leave it. I don't know m, leave it. But I know n is to the power of 4. This, again, can't be simplified. Nothing can happen here because I don't know I don't know m, I can't cancel anything. It's kind of a mess. And this is why we say we're going to treat this like a system. A system is where you try to plug one variable into another so that you can get them to kind of merge together. Remember how we used to do systems way back in first semester? We're going to try to get one variable by itself so that we can substitute it into the other equation. So I'm going to focus on the top equation, and I'm going to try to get one of these letters by itself. It doesn't matter which one, but I want to try to keep it simple. It looks like I is always the simpler variable. M is the one that always gets an exponent, so that looks a little more complicated to me, and I don't really want to mess with complicated things. So let's try this. Let's try to get I by itself in the first equation so that I can substitute it into the bottom equation. If I want to get I by itself, let's think about what we'd have to do. I is currently multiplying this m to the power of 1, which is just m. So if I is currently multiplying the m, to get rid of it, I want to divide the m to both sides. So I'm going to divide both sides by m. That's going to cancel the m, which is good, and that gives me I by itself, that's what I wanted, equals 12 over m. Now, it looks like I'm supposed to be able to solve that, but I'm not. I'm not supposed to be able to solve that. Instead, what I want to do is this. I want to take this I that I just solved for, and I want to substitute it into this little yellow part that I highlighted. Can you see where this is kind of going? I want to take this 12 over m, the part that I just got from my first equation, and I want to substitute it into the bottom equation, the one I couldn't even touch, instead of the letter I. So the bottom equation is now going to say 96 equals, instead of the letter I have 12 over m, and then in the parentheses I still have m to the power of 4. Now you'll notice I moved the power of 4 into the parentheses. It doesn't really matter whether the power of 4 is inside or outside. You can put it wherever you'd like. So now that I've done my substitution, let's take a look at what we're trying to solve, this equation. It's messy, but it is an equation that it looks like I can do because it's all got one variable. I can solve it as long as it has one variable. Now, the fraction is a little confusing, so I'll put m to the 4th over 1 to make it look like a fraction as well. That way maybe I can kind of clean it up a little bit. So I have 96 equals, if I clean up the fractions, I can multiply the tops, 12m to the 4th over, on the bottom, m times 1 is just m. So that must be the problem I'm trying to solve. 96 equals 12m to the 4th over m. Now that looks like a fraction, so I was thinking, oh gosh, is this going to be tough? Ew. But m to the 4th over m, we can clean that up a little bit too. That simplifies. Because m to the 4th is like saying I have 4 m's on top, 1 m on the bottom. I can cancel one of them out. So in reality, the 12 is just kind of going along for the ride, but I really have 3 m's left over, or m to the 3rd, if I cancel. And now let's see if we can solve that. How would this look if I wanted to solve? If I wanted to get m by itself, I could get rid of the 12. It's currently multiplying, so I can divide it to the other side. 96 divided by 12, if you have a calculator, is 8 equals m cubed. And then I can think to myself, okay, m cubed, something cubed is going to give me 8. You can do a cube root sort of thing if you want to do that, or you can just think about numbers. Something times itself 3 times is going to be 8. I can think of that number. The original m must be 2, because 2 times 2 times 2 3 times is going to give me 8 as an answer. If you wanted to, you could also do that power thing where you do the fraction power. This is currently 3 over 1, so you can do it to the power of 1/3, and you could do it to the power of 1/3. And in a calculator, I'll just show that calculation quickly. You can do 8 to the power of 1/3, and you'd get 2 as an answer either way. So regardless, we know that m is 2. Now as a reminder, we're solving a system. So that means I've solved one of the variables that I didn't know. I solved the m. Now I know that m is going to be 2. So I know that for sure. But I still need to solve for I. So I'm going to go back and I'm going to pick one of my original equations. It doesn't matter which one. And I'm going to solve for the letter I still don't know. I'll pick this equation on top because it looks simpler. The bottom one had bigger numbers, so I'm going to pick the easier looking equation. That equation was 12 equals I times m to the power of 1. So if I plug in the m that I just solved for, then I have 12 equals I times 2 to the power of 1. 2 to the power of 1 is just 2, so I'll clean that up. 12 equals I times 2. To get rid of times 2, I can divide by 2. And that means that I is equal to 6. So now I know that the I, or the initial value, must have been 6. Now, if you skipped the video where I did guess and check, you might not have noticed we already knew that from our guess and check. The initial value really was 6. And the multiplier really was 2. Now, comparatively, if you look at the YouTube stats and you can see the length of this video versus the length of the guess and check video, you can tell I got there by guessing faster than I got there with algebra. So that's an important distinction that you should make for yourself. Is it worth it to do all of this algebra if you can get there faster by guessing? Now, I personally got there faster by guessing, but maybe you don't. Maybe solving the system is faster for you. But it is worth noting and being honest. This takes a while. That's not to say you shouldn't do it this way, but it's worth being honest with yourself that it does take some time. Now, between now and the time that you watch the last video for letter D here, make sure that we understand what you just solved for and why. If you got lost in the process, don't worry too much. Use guess and check. I think that's fine. If you feel like the process made sense, that's awesome. Try the system of equations thing for all the other questions as well. I'll leave that up to you. In letter D, though, we're going to put it all together and make sure that we all have an answer, regardless of which way we got there. And then we'll try to clarify how to make sure you can do these problems for future examples.